Hello and welcome to Maths by SAS. This is my third lesson of D1, chapter number 1, exercise 1B. That is about LCM and HCF. In this class, students will be learning and discussing intermediate level question number 4. And let's read the question from the book. Question 4. As the question is long, so I've written the question in short form. Question 4 says that the numbers 792 and 990 written as the product of their prime factors are 792 equals to 2 cube multiplied by 3 square multiplied by 11 and 990 equals to 2 multiplied by this is 3 square multiplied by 5 multiplied by 11. Hence find the greatest whole number that will divide both 792 and 990 exactly. Okay, here the term the greatest number and that will divide both the numbers exactly is really important to understand. Whenever students, the situation is that you have to find the maximum or greatest, okay, or you have to divide something in the groups, what you have to find is, that is really important to understand. In all such cases, you have to find HCF. And when there is the repeated event and when you have to find the least or the smallest thing, in that case, you have to find the LCM. This is a technical point. This is the technical difference between the situations of HCF and LCM. Students, you have to focus on these all points because these are one of the important concepts of your O-level examination. So, as in this question, we have to find the greatest whole number which will be dividing both exactly. And when we say that some number is dividing the other number exactly, what does that mean? If I'm taking the example of 16, okay, if we say that 2 divides 16 exactly, what does that mean? That when I'm dividing 16 by 2, 2 8s are 16, and what is the remainder? Remainder has to be 0. So after working, we'll be checking whether the greatest number that we are getting, if when we divide 792 and 990 by that number, is our remainder 0? If the remainder comes 0, then that means that our answer is correct. And in order to find the greatest whole number, what we have to do, we have to find the HCF of the given numbers. And recall my previous lesson that how to find the HCF of given numbers. HCF of 792 and 990. We know that HCF is the product of common factors. Okay, so first I have to write the prime factorization of each number in index notation together. This is 792 and 990. 990 has the prime factorization, that is 2 multiplied by, let me reconfirm this, 3 square multiplied by 5 multiplied by 11. Now, in order to find the greatest number, HCF will be HCF. Now, if we look at 2's, we can see that here 2 has the power 1 and here 2 has the power 3. So 2 and the common factor has to come with the smallest power. So it will be 2. And if we look at 3, in both parts of the question, 3 has the power 2. So this will be common. And now if you look at 5, 792 doesn't have 5 in that, so there is no reason of coming 5 in the HCF. And if you look at 11, 11 is coming once. So in order to get the number, what we have to do, we have to get the product. 11 multiplied by 9 multiplied by 2 and this will become 99 multiplied by 2. 99 multiplied by 2, 9 2s are 18 and 119, 198. 198 is the number, it's the greatest whole number that divides, so the greatest whole number that divides or that will divides 792 and 990 is 198. And we said in the beginning that if some number divides other number exactly, then the remainder is 0. If I'm dividing 792 by 198, my answer is 4. And when I'm dividing 990 by 198, my answer is 5. So it means that my working is correct, and this 198 is the greatest, largest whole number that divides the given numbers exactly. Moving to the next question, and question says find the smallest value of n, smallest value of n such that the LCM of n and 15 is 45. Let's try to understand the question, because some of the students find these questions really difficult, and these are really important questions according to your O-level examination. The requirement is that we have to find the smallest value of n such that the LCM of n and 15 is 45. Now think, what is 45, students? 45 is the LCM of two numbers, okay? And out of those two numbers, one of the number is n and one is 15. Okay, now look, what we can do is, here you have to develop the thinking skill and visualization skill, that one of the number is n, and n must be having some prime factors. We do not know about those prime factors, okay, and must be having some prime factors, and the other number is 15, and the factors, prime factors of 15 are 3 multiplied by 5, and LCM of these two numbers, LCM 45 has the factors 45, 3 15 times, and 3 how many times? 5 times. This is 3 multiplied by 3 multiplied by 5. Now look, this is the answer which is already given to us. LCM is already given to us, okay? Now recall the definition of LCM, that LCM is the product of common and non-common factors. LCM is the product of common and non-common factors, and factors have to come with their greatest index in the LCM. Okay, 5. Now, how to develop the thinking skill, that one of the number is 15, and 15 has the factors 3 and 5, and 5 is one of the factor of given number, and 5 is in the LCM as well. 5 is in the LCM as well. And if you look at 3, we can see that in that number which is given to us, that has 3 one time in that, but LCM. But if we look at LCM, in the LCM the power of 3 is 2, as the LCM is the product of common and non-common prime factors, and the common prime factors have to come with their greatest powers index in the LCM. Now here 15 has 3 but with index 1, so in the question there must be number 3 square or 3 multiplied by 3 or 9 which is coming in the LCM. So the value of n will be 3 multiplied by 3, or n will be 3 square. I hope students you are really clear that how I'm deciding that what will be the smallest value of n, which is making the LCM of that number and 1545. Okay, moving to the next question. The next question says that two cars, car X and car Y, are at the same starting point of 2 kilometers track. Okay, at the same time, the car X and car Y make one lap every 60 seconds and 80 seconds. One lap, okay, every 60 seconds and every 80 seconds. The first requirement of the question is how long in seconds? How long in seconds will it take for both the cars to be back at the starting point at the same time? And the second is how long in minutes will it take for the faster car to be 5 laps ahead of the slower car? Let's try to understand the question, that how to decide that how long these two cars will be taking. And first of all, it's really important to understand that what is the meaning of the term lap. Okay, lap means a complete trip around the racing track that is repeated several times. Okay, I hope you are clear that the lap means a complete trip around the racetrack that is repeated several times. Now we have two cars with us, car X and car Y. Okay, let me hold the book. Okay, car X and car Y, and they are at the same point of 2 kilometers track at the same time. And car X and car Y make one lap every 60 seconds, and one lap, and this is taking 80 seconds to complete one lap. In order to find the first requirement of the question, that how long in seconds will it take for both the cars to be back at the starting point at the same time, as the situation is repeating again and again. So this is the situation, of condition of LCM. So first of all, we have to find the LCM of the given numbers by using prime factorization. Okay, so for 60, the prime factors are, I have to make the prime factors of 60 first. So I have to think about the number that can divide 60 completely to 30 times, and to how many times? To 15 times. So no more table of 2, 3, 5 times, and 5 1 times. 5 1 times. And for 80, let me make the prime factorization at this place. 80, again the unit digit is 0, so what can we do? Which smallest prime number is suitable? Always integrate your lesson with the previous lesson, because lessons of mathematics require continuous practice and integration with the previous lessons. This is 80 to 40 times, to 20 times, to how many times? To 10 times, to 5 times, and 5 1 times. Okay, so factors of 60 are, 60 can be written as a product of its prime factors. 2 2s are 4, 3s are 12, 5s are 60. 2 times 2 multiplied by 3 multiplied by 5, and this is 2 square multiplied by 3 multiplied by 5. And for 80, this is 2 to the 4 to the 8 to the 16 multiplied by 5. 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 5. So 2 how many times? 4, and multiplied by 5. Now, in order to get the answer that how long in seconds will it take for both the cars, time taken by both the cars, time taken by by both cars, we are going to take the LCM. Okay, and recall that what is the meaning of LCM and how to get the LCM. LCM is the product of common and non-common factors, and common factors have to come with their largest index. So if we look at 2, here 2 is having power 2 and here 2 is having power 4. So 2 will be coming with what power? 2 raised to power 4 multiplied by 3 is not coming in the second number, so as it is, and 5 is coming with index 1, so it is 16 times 3 times 5. Now look, as this is a paper 1 question, so we will learn how to make the calculation easy. 16 5s is 80, and 80 times 3 is 16 5s is 80, and 80 times 3 is 240. Okay, students, you can see that I'm giving you the idea that how can you make your calculation easy. If I'm going for 16 3s are 48 multiplied by 5, I need to put some struggle. But if I'm going with 16 multiplied by 5, okay, 16 5s is 80 times 3. For some time I will be forgetting this 0, and 8 times 3 is 24, and then I have to put the 0, and this is 240 seconds. So time taken by both the cars is 240 seconds. And the second part says that how long in minutes will it take for the faster car to be 5 laps ahead. Okay, so the time taken for second car, faster car, time taken for faster car what we have to do, we will be multiplying and it has to be for 5 laps. Okay, for 1 lap they are taking 240 seconds multiplied by 240, and now 5 times 0 is 0, 5 4s are 20, 5 2s are 10, and 2 12 seconds. And as we have to give our answer in minutes, and we know that 1 minute equals to 60 seconds, and 1 second equals to 1 over 60 minute. So what we have to do, I have to divide this answer 1200 by 60, and my answer will be in minutes. 0 goes with 0, 6 1s are and 6 2s are 20 minutes. So the required time will be 20 minutes, and let me encircle these two answers so that my junior students especially can understand the answer, that here the time is 240 seconds, and here first we are obtaining the time taken by faster car to cover 5 laps, and for that purpose the answer is coming 1200 seconds. And as the question says, to give the answer in minutes, and in order to give the answer in minutes, we know that 1 minute is having 60 seconds. 1 minute is having 60 seconds. So 1 second will be equal to 1 over 60 minutes. And then I have to divide that answer by 60, and my required answer will be 20 minutes. Really important questions according to your O-level examinations. So please watch and understand these all lessons properly. And now it's a time to go for the last question. And the last question is that again the LCM of 9, 12 and the number n is 252. Now if n is odd, and find all possible values of n. Again, try to understand that there are 3 numbers, 9. We know that LCM is the product of common and non-common prime factors. So the prime factors for 9 are 3 multiplied by 3, or 3 square, and for 12 for the junior students, I will be making the prime factorization 2 6 and 2 3 2 multiplied by 2 multiplied by 3, and this gives me 2 square multiplied by 3, and there is some third number as well that will also have some factors. Okay, we do not know, it's a guess game. Okay, and LCM of these all numbers, LCM equals to 252. Let's write 252 as a product of prime factors. 252, 2 1s are 2s are, and 2 6 are, 2 6 are and 3s are, and then 3 2s are 1s are, and 3 7 times. Okay, now prime factors of 252 are 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 7, or in index notation what can we write? 2 square multiplied by 3 square multiplied by 7. Okay, now look students, we have to find the third number, which when we're writing with these two numbers giving us LCM 2 square multiplied by 3 square multiplied by 7. Okay, now let me write the factors once again at this place for the thinking purpose. 3 square, and this is 2 square multiplied by 3, and the third number we do not know. Third number we do not know. That will also have some factors. That will also have some factors. And LCM is 2 square multiplied by 3 square multiplied by 7. Now let's talk about the possibilities. Okay, students, we can see that the question says that we have to find the possible values of n, but n has to be the prime number. N has to be the prime number. So for that purpose, one point has to be really clear, that we are not going to involve any power of 2 or any 2, because this is a rule whenever we multiply some number. Like if I'm taking even the odd number 3, when I'm multiplying it by 2, the answer comes even. 9 times 2 is 18, that is even. So there is no chance that n can take value 2 or 2 square. Okay, so it means that this 2 is discarded. Now we have to focus our attention on 3 and 7 because both are odd numbers. Now look, that 3 square is in 9 and 3 is in 12. Okay, and LCM is having 3 square. So there can be the possibility that 3 square in the LCM is coming from 9. But if we look at 7, 7 is in the LCM but not in the other two numbers. So one of the possibility of value of n can be, one possibility can be 7, and 7 is the odd number. And let's talk about the second possibility. Even if I'm taking, I have to make the LCM, my LCM has to remain 2 square, 3 square and 7. If as the LCM contains 7, if I'm taking n, one of the factor of n 7 and one factor 3, okay, even then n can be 3 multiplied by 7, which is equal to 21. Okay, and the next value of n can be, okay, even if I'm taking one of the factor 3 square multiplied by 7, 9 times 7 is 63. So the possible values of n can be 7, can be 21 or 63. Students, I hope you are really clear that how we are deciding that which possible value we can give to the unknown numbers such that the LCM remains same. one of the important concepts of your O-level examinations. I hope students you are really clear about today's class. In today's class we learned about the situations when the question says that find the greatest whole number that divides the given number exactly, or when the LCM is given and one of the number is given and we have to find the other number. And then we talked about if the question is about the smallest or minimum situation, or the term altogether or together is used, or some events are happening simultaneously. In all such situations we are going to calculate LCM. This is the key point that you have to keep in mind, that for the greatest or maximum situation you have to find HCF, and for the least minimum or together and simultaneous situations you have to find LCM. Then these lessons will become really easy for you. With this lesson we have completed the full package of prime and composite numbers, prime factorization, and LCM and HCF. These all lessons are really important, not for my class 6 and 7 students, but for O1, O2 and O3 students. So please watch these lessons and try to understand the lesson. Please watch my lessons, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.